Hello everyone. So in this session I'm going to complete the example which was incompleted in our last session, right? And that was from the case 3. So I'm continuing with this sum only, and the sum and the question was xy double dash plus 2y dash plus xy equals to 0. So in this example we just did the simplification. Okay, so I'm just moving forward for this one. This one was our last step, that is this one, that is here we are getting three terms. First for k equals to 0 terms, for k equals to 1, and last one that is starting from 2 to infinite. Okay, so now next one, continuing with this. Okay, after this, hope you all know that what we are doing after this, right? That this all the terms equals to, you have to put 0. It means you have to equate the terms. So equating the coefficients of x square minus 1 to 0, it means you have to equate the terms. So all the terms of x, all the coefficients of x will be 0. So the first term is you are getting is m into m plus 1 c0 equals to 0. But as you know, c0 would not be possible 0. Okay. So m into m plus 1 equals to 0. So that you can find here m equals to 0 and minus 1. Till this part all the cases are same. Again I am repeating the sentence till the part of m. All the three cases are same only. Okay. Now from this the cases will be split. That is in first case or second or the third case. So see here you are getting the roots are 0 and minus 1, and that is actually these both are different, and it is differ by a integer. You can see that one is 0 and the second one is given minus 1. Okay, so which is distinct and differ by a integer. Okay, so after this you have to write this one. So taking m1 equals to minus 1, you, as you know all, the third case you have to apply for the smallest root only, and from this both the root 0 and minus 1, the smallest root is minus 1. Okay, so taking m1 equals to minus 1 and m2 equals to the 0. Okay, so after then you have to check that m minus m1 minus m2. So I'm just checking here, m1 is minus 1 and the m2 is 0. So minus 1 minus 0, that will be minus 1, and which is belongs to z. As you know, it will be positive or negative numbers. So here we are getting negative, that is minus 1. So third case will be applicable. Now again second term you have to equate, and that is this one, m into, sorry, m plus 1 into m plus 2, c1 equals to 0. Okay, so putting this both the values here one by one, you will get c1 equals to 0. Maybe you can check that. Okay, first I am putting here minus 1. So minus 1 plus 1 0, yani ki you will get indeterminate form. Okay, so for the smallest root m equals to minus 1, c1 is an arbitrary constant as 0 upon 0, because apply these both the terms in this denominator, m plus 1 m plus 2, putting m equals to minus 1, right? So minus 1 plus 1 0, so you will get 0 by 0 form. So that will be your arbitrary constant, that will be your first arbitrary constant. Okay, so c1 is indeterminate and the c1 is an arbitrary constant for m equals to minus 1. Okay, so जो भी indeterminate component मिल रहा है, okay, that will be your arbitrary constant. It means आपका आंसर उसी में आएगा अभी. Okay, now third term equals to 0 again. So m plus 1 into m plus k plus 1 into ck plus ck minus 2 equals to 0. From this you have to make a subject of ck, right? So that will be ck equals to minus ck minus 2 upon m plus k into m plus k plus 2. Okay, now you have to check its boundary, and that will be here k is greater than or equals to 1. Hope you all know now. Okay, So for the k equals to, sorry, just leave this, it's there is no needs to write. Okay, now part 1, see the part 1, and that will be for the smallest root only. So the smallest root is m equals to minus 1. So put m equals to minus 1 in this equation, that is the equation of ck. Okay, so ck equals to minus ck minus 2 upon k minus 1 into k, where k is greater than or equals to 2. Now you have to apply one by one all the cases for k, one by one all the limits of k, right? So k is starting from here, we have fixed its boundary, that is from 2 to 2 up to this one. See here. Okay, so starting with the k equals to 2, so c2 equals to minus c0 upon 2 into 1. So that will be minus c0 by 2. c0 is already constant, as you know. Putting k equals to 3 now. So c3 equals to minus c1 upon 6. As you know now, c1 will be works as an arbitrary constant because c1 you have got infinite. Okay, so जो indeterminate number मिल रहा है, okay, that will be your arbitrary constant only. Okay, suppose you are getting indeterminate form, that is in C5. Okay, so what will be your arbitrary constant? That will be C0 and C5. Now suppose you will get C3 equals to 0 by 0, right? That is here. So C0 and C3, that will be your arbitrary constants. Okay, now starting with the k equals to 4, so that will be minus C2 by 12. So again putting this the value of C2, so finally you will get C0 upon 24, same as for C5. Okay, okay, now next it's series solution, and that is y1x equals to k equals to 0 to infinite the k x prime plus k. So as you know, m is common, so taking common excess to m, so the remaining term will be summation k equals to 0 to infinite ck excess to k. Okay, now expand this series. As you know, m equals to minus 1 here, so x equals to minus 1, expanding, so c0 plus c1x plus c2x will up to this on. Okay, now you have to put all the values of this, all the constants. C0 is already constant, c1 that we just put in previous page, that is c1 equals to 0 by 0. So as it is being the indeterminate form, we are converting it into the arbitrary constant. So c1x as it is, c2 we have in minus c0 by 2, same as putting all the values. Okay, excess to minus 1, m yani ki minus 1, that is for smallest root. Now take out common c0 and c1. Okay, so I'm just rewriting this term, that is this one. Okay, and this one x to minus 1, it means we can also write x upon 1. So c0 upon x. Okay, and the remaining term is here. Okay, so case 3 we did first part, and that is for m equals to minus 1. There is no need of second part, as I have written into the notes, you can see that. Okay, so यहाँ पे आपको second part करना ही नहीं है. Whenever you will get constants as an infinite, sorry, as an indeterminate term. Okay, अगर आपको कोई constant indeterminate मिल रहा है तो उसमें आपको वो करना नहीं है. ठीक है, part 2. So this will be your final answer only. No need to go for next step, no need to go for the further procedure. Okay, so the example will be end here, and next session will start, we will do more practice. So I'll start the second example in our next session. Okay, so till that just do this practice and continue with your, note it down in your paper pen, and always keep it with notes. that key notes. Okay, just keep it with you and then just do the practice. Okay, thank you.